Trigonometry, Chapter 6, Inverse Circular Functions and Trig Equations, Section 2, Solving Trig Equations, Video 1, Basic Linear Trig Equations, Part 1. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous section, we reviewed inverse functions in general. We also determined the domains and ranges of inverse trig functions. Additionally, we learned to simplify some compositions of trig functions with inverse trig functions, both numerically and algebraically. In this section, we learned to solve a variety of trig equations. In this video, we learned to solve a basic linear trig equation. This skill will be the final step for more complicated equations, so learning this skill is a must. Recall from algebra that a linear equation is an equation whose degree is 1. In other words, whose terms contain a maximum of one variable. For example, x plus y plus 3 equals 2 is linear. All four of the terms, the x, the y, the 3, and the 2, contain at most a single variable. However, xy plus y squared equals 1 is not linear because of its three terms, xy, y squared, and 1, two of them contain more than one variable. The first one contains an x and a y. The second one contains a pair of y's. A basic linear trig equation is a trig equation involving a single trig function whose power is 1. For example, 2 sine of theta plus 1 equals 0 is a basic linear trig equation. The initial steps for solving a basic linear trig equation are straightforward. For example, to solve 2 sine theta plus 1 equals 0, you probably already know the first two moves. Stop and think for a second. If I said solve for theta, what would you probably do first on both sides? And what would you probably do second on both sides? Well, you're probably correct. In general, though, the first move is to isolate the trig function. In this example, we would isolate sine of theta by first subtracting 1 from both sides to get 2 sine theta equals negative 1. In other words, we would do this. Subtract 1 from both sides and get 2 sine theta equals negative 1. That gets me closer to having the sine by itself, but then we would divide both sides by 2, and we would end up getting sine of theta equals negative 1/2. Let's assume this first move requires no further explanation because the moves are basic algebraic moves. Once you've isolated the trig function, we now find the solutions in whatever interval is provided at the start of the problem. If no such interval is stated, we assume we are finding a general solution. For example, let's say we're asked to solve 2 sine theta plus 1 equals 0 in the interval 0 to 2 pi, which is one trip around the unit circle. Notice it doesn't include 2 pi because that's the same terminal point as 0. After isolating the trig function to get sine of theta equals negative 1/2, we find all solutions in this interval. Now, some of you are thinking, I can just pull these off a unit circle, and you're right, but there will be times when we can't do that, so we're going to look at a technique that always works. To find all solutions to sine theta equals negative 1/2 in the interval 0 to 2 pi, we need to determine the correct quadrants and the reference angle to place in those quadrants. For the quadrants, since our trig function is sine and the constant is negative 1/2, sine negative 1/2, we're looking for solutions in quadrants 3 and 4, where sine is negative. Remember, all trig functions are positive in quadrant 1. Sine and its reciprocal cosecant are positive in quadrant 2. For the reference angle, since reference angles are always acute, less than 90, we find the inverse trig function of the absolute value of the constant. So even though our equation has negative 1/2, when we do inverse sine, we're going to ignore the negative and do inverse sine of positive 1/2 to guarantee to give us an acute angle. Sine inverse of 1/2 is pi over 6. Hopefully you know your special triangles. After you've found the quadrant and the reference angles, quadrants and reference angle, place the reference angle in the correct quadrants and measure from standard position. For example, in quadrant 3, if we put a reference angle of pi over 6, it's kind of green dotted here, and measure it from standard position, then it's a semicircle, which is pi radians, plus pi over 6 Altogether in red, 7 pi over 6. In quadrant 4, if we put the reference angle, and remember the reference angle is always measured from the x-axis, we put a reference angle of pi over 6, then the angle measured from standard position, red, along with the pi over 6 should give us a complete revolution, 2 pi. So our red angle is 2 pi minus pi over 6, which is 11 pi over 6. So the solutions to 2 sine theta plus 1 equals 0 in the interval 0 to 2 pi are theta equals 7 pi over 6 and theta equals 11 pi over 6. If we're asked to find the general solutions to 2 sine theta plus 1 equals 0, in other words, all solutions regardless of how many revolutions, we first find the solutions within one period, usually 0 to 2 pi. Then we add an expression to represent periods added to these specific solutions. Since the period of sine is 2 pi, the general solutions would be theta equals 7 pi over 6 plus 2 pi n, and theta equals 11 pi over 6 plus 2 pi n, where n is an element of the integers. In other words, n can be a positive or negative whole number to count how many extra revolutions to add to our specific solutions, either in the positive or negative direction. There's no now you try for this video. It will follow the next video, so I encourage you to watch the next video.